Can everyone hear me? Is this good? Yes? All right, very cool. This is epic. I have to take a photo first. So smile. This is going to be panoramic. Yay! All right. Wait, that was too dark. Hold on. iPhone. Here we go. 1, 2, 3. Wow. Very cool. Thank you. So thank you for coming to this session. This is a very short session, by the way. We only have about 30 minutes, and I don't want to run late, so let's get started. So hello, everyone. My name is Ray. I'm a developer advocate for the Google Cloud Platform. I just flew in here. I landed in Brussels this morning at 7:30 a.m. from San Francisco. So it's literally 4:30 a.m. for me right now. And I think I had 4 or 5 cups of coffee already. I have moved on to sugar, but I don't have anything right now. So if you have anything you can toss at me, please. Like, I need some sugar right now. So if you have any questions about this session or anything you want to ask, come and find me later. And my colleague, Frances, is actually here in the front row. Or you can actually find me on Twitter at Satanism. Aside from technology, my other passion is about traveling. I love to travel. I love to backpack. I came here with one backpack. I'll be on the road for about 1 month. And I like to take photos, and that's why I'm always behind my camera. And if you are also liking photography, anyone likes photography here? All right. You can go check out my Flickr. That's my username, Satanism, as well. That's actually me walking in the middle of the desert in northern China. Only because I was a cheap backpacker, and somebody told me if I go to this desert and walk for about 4 hours, I will find a real oasis, and I can stay there for free. So anyone walk in the desert before by yourself? Yeah, quite a few. Yeah, some people has. It's not easy. It's quite scary because 2 hours in, when you look back, there's nothing behind you. When you look front, there's also nothing behind you, in front of you either. So it can be quite scary. I will not do that again. So I'm here to talk to you about Kubernetes and one of the most powerful feature I think about Kubernetes, which is the thank you, yes, chocolate. Thank you so much. Woo! Thank you, yes. And one of the most powerful feature about Kubernetes is its API, which not many people knows about. And I'm going to demonstrate some of these things through a autoscaler that I wrote just for fun and for demonstration purposes. It's not for production use, but I think it taught myself a lot of things. Quick question, how many people knows about containers? All right, you're in the right place. How many people knows about Kubernetes? All right, use Kubernetes as well? What? Have you seen Kubernetes in action? Anyone? All right. So I think that determines how much in depth I'm going to go into Kubernetes. I'm probably just going to cover at the very, very high level. I'm not going to go into all the details because I think there's another session behind us that will talk about the other things like replication controllers and pods in more detail. But for my purposes, I'm just going to illustrate a few points at a very high level. So Kubernetes is this open source software that Google contributed originally. It is a container orchestrator. Basically, what that means is if you have a container that you want to run at scale in a production environment on multiple servers with multiple instances, you should be using some kind of orchestration tool. And one of them is Kubernetes. And it is actually created based upon many years of Google's experiences in running containers. Okay? And it's open source, and it's also written in Go. And you can actually find it on GitHub. Everyone has found it on GitHub already? Yeah? Some people? Anyone contributed to it? All right, contributor. Very cool. So how does it work? Again, at a very high level, for those of you who may not have seen it, basically what you can do is to create your container image, push it into a repository, like Docker Hub, or you can push it into a private repository. And then you can write this configuration file to define which container image do you want to run, and then how many instances of that do you want to run. And also define how much resource do you want to run for that particular instance of the container. And then once you have that, you can push it to what we call the Kubernetes master, and that will then consult the scheduler. And then the master will actually be controlling multiple workers. So like in a Kubernetes cluster, you may have 2 workers or 5 or 10 or even 100 virtual machines or physical machines, it doesn't matter. And it will actually go and ask each of the machines to say, hey, do you have enough resource, enough capacity to run this container for me? And if it does, then Kubernetes will then instruct that node to pull down the image and then executing it. And you can actually say, well, I need one instance of it right now, or I need 5 instances of it. And it's just going to go ahead and find the different nodes, different virtual machines or physical machines to run your workload for you. And that is very different from how at least I have been doing things before, which, from coming from an enterprise background, what I have been doing things before is, before the project even started, I have a set of machines that's assigned to me. And then I say, well, that machine is .1, .2, .3, and I go ahead and physically install my software onto it, right? In this model, you basically don't care about those machines at all. You just need to know how much pool of resources you have, and Kubernetes is supposed to be able to best utilize that pool of resources. So you don't have to deal with individual machines anymore. Okay? That's very, very high level. It is open source, and every time I see this slide, I have to update the numbers. We have like 12,000 plus stars, many, many contributors. I think there are more contributors from outside of Google now than from Google itself, so which is fantastic. It's a very, very active and vibrant open source community at the moment. And you can find other community channels from Kubernetes.io. They have a Slack channel which you can join and talk with the developers and engineers who actually work on these things. And just learn how to do whatever you want to do. Okay, so this talk is about scaling. Basically, how do you actually use Kubernetes to auto-scale? But more so, I want to illustrate the aspect of it, which is the API. Okay, auto-scaling is just one aspect, but the more important part of it is the API. Okay, and the thing I'm going to scale is called infinite span. I don't know how many people heard about infinite span. Anyone? All right, you must be Java developer. So am I. It is a Java key value in-memory cache store. So for those of you who need something else to relate to, you can think about Hazelcast or Redis or something like that, where basically you can have a pool of these instances that's up and running. These are infinite span nodes. And you can just push these data, like key value pair data structures, into this cluster of cache. And infinite span is going to be smart enough to be able to, at its best effort, balance the data to be stored on different physical nodes. Okay? So in this case, I have 3 different records, and they are all spread out across 3 different infinite span nodes. It can also do another thing, which is to be able to replicate. Okay? You can replicate your data so that in case one of the nodes goes away, you at least have another piece of the data somewhere else. And it will actually then again to figure out, okay, now I only have 1 copy of this piece of data. Let me go ahead and make sure there are 2 copies. Okay, so there is some fault tolerance built into it. So it's okay if one of the nodes just goes away because you have 2 pieces of the copies anyways. If you're running out of capacity with infinite span with this type of system, all you have to do is just add another node, start another server. And immediately, the resource for that node, like in Java, we call like the memory resource the heap. That heap will then becomes part of the rest of the cluster, and now you instantly have more space to store your data. And it will also auto-balance the data for you again. Okay? So with that, let's see it. So I have infinite span running in Kubernetes. And the basic one I'm going to show it is by visualization. Oh, what is going on here? I need my Wi-Fi. Everyone, stop watching YouTube or something. Anything. All right, here we go. I think that should work. All right, whew, thank goodness. Just so you know, I was at DevOps Belgium, and I was doing the demo. Not this one, but something different. And I discovered I had no Wi-Fi. And I had to run the entire presentation from Francesque's iPhone, or Android phone. Yeah, I'm sorry. Yeah, it's tethered to his internet connection. There you go. So here we have infinite span nodes running. I have 2 nodes running. And these things are actually running in my Kubernetes cluster. And let me just show you here. Whoop. See, make sure you can see it. So here I have my cluster. I can say get nodes. Basically, what this is showing you is that I have 4 virtual machines running behind this. So my Kubernetes cluster has 4 machines. And whenever I'm running a new infinite span node, it will get automatically scheduled to one of these machines to run. And I can actually see, for example, how many of these instances are running. And in Kubernetes, these are called pods. And you can see here, I got 2 of these pods running. So the infinite span controller with the random string behind it is one of these circles that's running around. Okay, and so this is what you can actually do. So I'm actually going to go ahead and do something that might demonstrate a little bit about the scaling. So I'm going to go ahead and get into the inside of the cluster. And the way I can do it is by using this kubectl command called exec. So if you use Docker, you know Docker exec is very similar. So that it will just drop you into the container that's actually running inside of Kubernetes. And it's going to be able to do this securely. Okay, so if I do this, now I'm inside the Kubernetes cluster because I have a pod running that I can exec into. And in here, I have this demo application, which is a Java application. And what this can do is I can say, I need to create 100 entries, 100 data records I want to put into this infinite span cluster. And I need to specify the server to put this in. And oh, this is interesting because I have two nodes. I have two nodes here. You can see that each of the node is having a different IP address, right? But rather than specifying each of these IP addresses individually, I have created what's called a service inside of Kubernetes. And so that will actually create a DNS name for me. So all I have to do is to specify the DNS name, and that will automatically get resolved to one of these IP addresses for me, which is really, really powerful. So then what I can do is to create 100 of these records. And you can see that this is populating just like that. And I slow it down quite a bit, because otherwise it would just like boom, and then we're done. So I actually slow this down for the visual effects, OK? And so what I can do then is I can scale this. I can say kubectl scale RC, which is the replication controller, which can control how many of these instances I need to run. And I'm going to say, I'm going to scale our infinite span controller. And rather than 3 instances, I need to run, rather than 2 instances, I need to run 3. So hopefully that works, kubectl scale RC. So what just happened is I told the replication controller that I need 3 of these instances. Please go ahead and figure out how to run this, okay? And behind the scenes, what this is doing is, okay, let me go find the machine to run this new infinite span instance. And I found it, and let me go ahead and start it. Okay, so this is in the starting process. And once the new node joins, you can see that another circle popped up, and the data got distributed again among the 3 servers, right? Now remember, I put 100 entries in there. The sum should be about 200. And because I have 3 servers, so that when you divide it up, it's about 66 entries per server. And that's just about right. If I were to scale this down, let me do that. It's going to randomly kill one of the nodes, and there it goes. Now, because I have duplicate data, right, I have 2 entries of the same data for every piece of the entries. If I kill one of these instances, they still have 100 entries in total. So eventually, they're going to get synced up again, and each one of these nodes are now, again, having 100 instances. Okay? Does that make sense to everyone? Yeah? Very cool. So then I thought, wouldn't it be nice to autoscale this somehow, right? And this autoscaling is very different from what people have been doing or being used to do. And keep in mind, I have never written an autoscaler before. This is actually one of the very first time I look into how to write an autoscaler, and I learned quite a lot from it. Actually, how many people here has written an autoscaler before? Yeah, quite a few. OK, very cool. So they probably know a lot more than I do. So if you see anything, please let me know. I love to learn as well. So this is what I understand so far. The easy things about autoscaling is that, well, it's easy to scale out, especially the stateless workload, right? These are the things that have no state, no data. So you can actually scale out and in as much as you want. And they're mostly CPU bound. So the metrics that you look at are mostly system metrics, like CPU utilization. Okay, those are the easy things to do. In fact, Kubernetes 1.1 can do this out of the box. And it is called the horizontal pod autoscaling based on the CPU utilization. So if you go online and search for horizontal pod autoscaling, you'll find documentation on how to do this. Now, I can demo it as well, but I just don't have enough time. If I have time, I'll show it to you. It's just that For it to auto-scale, it will take maybe 3 to 5 minutes because they want to get rid of the noise, so the duration is a little bit longer. Okay. But what's more difficult is how do you actually auto-scale things like a stateful workload, like infinite span, and not using CPU metrics, but using custom metrics, and scale not just out, but also scale in. Because when you're scaling in, you cannot kill all of the instances at once, right? At most, you can probably only kill one instance at any given time. So what I'm going to show you today is actually how to do this. But more importantly, is that understanding that there are actually APIs you can use behind the scenes. Okay? And this is the pattern that I put together based on what I learned so far. Basically, you have your instances running, like these are your app, and your app is probably exporting some kind of metrics. And the metrics has to be collected by what we call like maybe a metrics collector, and then push that metrics up to a metrics server that gets stored into a store. So periodically this is going to say, how many entries is in my infinite span node? 10. All right, let me send it through. And then there's a component called the autoscaler, which will then pull down these metrics like aggregate average over time. So it's going to say, what is the average utilization of my cluster in the past 20 seconds or in the past 1 minute? And it's going to take that average utilization and compare it with a threshold. So for example, if you say the threshold is 85% and your average has been 100%, then you're over threshold, and in which case you may need to scale out, right? If you're underutilizing, then you may have to scale in. So the autoscaler will then is the one that's responsible for making that decision and determine how many instances do you have to run. And then it's going to take that number and then give it to what we call the actuator, which is a component that will actually scale out the instances for you. So you tell the actuator, OK, I need 5 instances now. Please go ahead and instantiate it. The actuator then will see how to actually instantiate that instance of the application. Basically, usually there's a template that you have to define. And based on the template, it's going to instantiate the application for you. So for the custom metrics and custom scaling, what I have to do is to create these 2 components myself, the server and also the autoscaler. The actuator, the template, and the actual instantiation is actually just being done by Kubernetes, right? I just show you how you can do that via the command line. So in my autoscaler, I don't want to be calling my shell every single time, right? Because I don't want to be like, hey, kubectl, scale RC, and set the replicas myself. What you can actually do is to use the Kubernetes API. Everything that you do from the command line is actually exposed from the API somehow. It's a RESTful API. So let me show you what I mean. So for example, if I do a kubectl get pods, which is showing me all the instances up and running currently, I can actually go to the RESTful endpoint for that. I don't know if you can see namespace. Oh, can I zoom in? No, that's not it. No, I don't know the combination. But on the top here, you can basically see I'm calling the API v1, and I'm getting a list of pods. And if you go to this endpoint, you will then see the pod list. And from here, it's just a JSON payload, and you can see all of the pods that's running in this system. If you want to see another resource, for example, the Replication Controller, which is the one that can scale in and out for you, you can just say, go to that endpoint as well. So let me go ahead and find the infinite span controller for me. And there's a self-link, which I can copy and paste. OK. And I can drill into this specific replication controller, and you can see the current state of this replication controller. And the takeaway here is basically that, well, in this RC, currently there are only 2 replicas, meaning that there are only 2 instances up and running. With the API, it's a RESTful API, so what that means is you can actually modify this by doing a put operation on this endpoint. So for example, I can go ahead and go to temp, and let me just curl this infinite span controller definition. That's the current state. I'm going to put that into a temporary JSON file. And then I'm going to open it up, and I'm going to change the replicas to 3. Once I've done that, I have this payload I can put back into the server via the RESTful API. And that payload, you can do a put operation, put method on this, and just put back into that controller. Okay? And if I do that, if I go back to this visualization tool, I just did it. If I do get pods, you're going to see that the replication controller was actually updated, and now it's actually going to try to start another pod. And soon enough, one of the new nodes just appeared. And you can use this technique to make modifications to your Kubernetes cluster for any of the resources that it exposes. So this applies to pods, replication controller, autoscaler, namespaces, anything. Anything you can think of is actually accessible in this manner. There's a catch, though. What I have just done was without any security, right? I just went to an endpoint without any authentication. But that is only because I am running a local proxy on my machine. So the proxy already authenticated with the server. If you're trying to do this inside of the Kubernetes cluster itself, you have to be able to authenticate the call. And let me just go back to this, go back inside of the cluster. And so, for example, if I were to try to get a pod, let me make this shorter. If I do curl, it is not localhost anymore. You can access the API server by just saying Kubernetes. And it is a HTTPS endpoint. Whoa. Okay. If you do this, it's going to tell you you cannot access it. Well, there are two reasons for it. First of all, it's HTTPS, so you don't have the certificate. And the certificate is actually stored in what we call a secret, a Kubernetes secret. And that gets mounted into your file system. And you can actually find the secret here inside the pod under this directory. And here you have the certificate and you have the token. So what you can do is say ca cert is equal to ca.crt. Oh. What's that? Oh, sorry. Yeah, that was the CD. Yeah, good catch. Yeah, so let me do that again. Ca cert is equal to ca.crt. Or maybe without the equal. Yeah, there we go. So now we are able to verify this HTTPS connection, but I still need to authorize myself by using the token. And the token is actually stored in this file called token. Okay? So all I have to do is to copy and paste that string into my header, but I'm not going to do that. What I can do is to do header authorization, bear, and then I'm just going to read it in like that. Okay? And now from my pod, I can actually access the Kubernetes API from the pod directly. All right? So that's just the half of the story, right? Now we know how to access the API. We can actually make modification to the Kubernetes cluster, and using the replication controller as the actuator to scale in and out the pod. What we then need to do is to make sure that our autoscaler is doing the right thing. So in your application, let me check the time. I only have about 4 minutes. So in the application, you have your application that's exporting the metrics, and then you need to have this metrics collector that's collecting it. Well, if they're both running in containers, how do you put them together? Because in a container, you're supposed to just run one single process per container, right? You're not supposed to be running multiple processes in a container image. And the way that you do that is to define these containers separately and then run them as a pod. That's a Kubernetes concept. Basically, they share the same namespace, and they share the same resources. They share the same IP addresses. So you have two containers, and the metrics collector can actually just talk to the application container directly with the same IP. One thing I want to mention is that the metrics collector will be collecting metrics, like, say, every 10 seconds or however long now you define. There's a catch. It works wonderfully when you're just adding new nodes. When you're taking nodes away, what do you have to do? You have to take some of these metrics away as well, because otherwise your metrics will be screwed, right? It will be too much because these pods don't exist anymore. These instances don't exist anymore. So you need a way to basically get notified when something happens, especially when something got removed. And in Kubernetes, there's another concept. It's called watch. Okay? So what that means is, for any one of these endpoints, rather than just doing a curl, which just give you just one response back, you can do a watch is equal to true, and all of a sudden, this is a string. So every time anything happens in the cluster that happens to change the number of pods, you'll get notified here. So as you're scaling in and out, you'll get notified here as well. So you can watch for this string for any changes to your cluster, which is pretty cool. And just to show you how the autoscaler works in total, because I think I only have about 2 minutes left. Wow. I exposed my autoscaler component in the public IP address here. And what I can do is I can create a new autoscaler definition, which consists of the threshold, like how many items do I want per node, and the minimum numbers of instances and the maximum number of instances I want. And I can actually send this to my autoscaler right now. So I can do create autoscaler with the IP address. No. What's going on here? Oh. Well, I'm not sure, but let me try delete. Oh. OK, so I deleted it out. Let me create another one. There we go, created, perfect. And let me go back to the visualization tool. And now my autoscaler is actually listening, watching for these changes. The matrices are coming in. It's watching and listening to the pods coming in and out. And so theoretically, if everything works, if I go back to this cluster and run this app again, and let's just say I'm going to do 300. No, let's do 500 entries. And the server is just infinite span, right? So what is that going to do? It's going to put a total of 1,000 entries into this cluster because we have 2 replicas for each of the entries. What that then translates to is I'm supposed to get about 10 servers or 10 infinite span instances up and running. Okay, so if I do that, and this is where I make or break the demo. There you go. So things are increasing. Again, it's for, if I go and get the pods, oh boy. Not enough, yeah. Come on. Oh, there we go. Did you see that? All right, so just so you know, the autoscaler doesn't run constantly, right? Because if you do, it's going to read data as you are creating new instances and getting rid of instances. So you get a lot of noise. Okay. For demonstration purposes, my duration between how often it checks is very short. But what that also means is that there will be a lot of noise. In the real autoscaler, you probably need the duration to be much, much longer. Okay. There you go. So I'm still putting more and more entries in here. So eventually, this will grow and grow until we get maybe 10 of these infinite span nodes up and running. There you go. Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah, pretty cool. Not bad. And let me see about the health of this. So there's a catch, right? The pod can actually grow and grow and grow. Even though I set a cap on it, if you don't set a cap on it, you just keep on growing. But you still need to have the physical underlying infrastructure to support that many pods. What I don't have right now is to be able to, say, autoscale the underlying infrastructure. Because if you are running on a physical infrastructure, you have to put in the actual machines. On the cloud, what is pretty cool is you can actually make an API call. So what you can do is to detect that something is pending because it doesn't have enough resources to run, then you can just make an API call to potentially scale out the number of physical or virtual machine that you have. And just one last thing, every magician has a disappearing trick. So what I'm going to do, well, actually, you know what? Does that button work? Clear cache? I don't know. Let's try it. Maybe not. So I haven't used it for a while. So what I'm going to do is to do Java jar and operation clear, and the server is infinite span, and that should take away everything. Boom, gone. But notice it's not removing all of the instances at once, right? It doesn't do that because if you do that, you may actually lose data. So what this is going to do is every single time when the autoscaler kicks in, it's only going to remove one instance at a time. All right. So we'll let that run for a while. Let's see how much time I got. Oh, I'm over time. So yeah, that's about it. Thank you. Yeah, try Kubernetes today. Thank you. Important takeaways: the REST API, filter, tokens and certificates, and the watch for events. All right.